Hi everyone, and let's do the next question. Next question looks very tight or tough, but it's very simple question. And the question says diagonal BD of a parallelogram ABCD intersects the line segment AE at point F, where E is any point on the side BC. Prove that DF into EF is equal to FB into FA. Whenever we have such questions where we have to prove DF into EF or is equal to FB into FA, it should strike to you that these are something like ratios. Ratios means similar triangles, and similar triangles means if we can prove two triangles are similar, then we can get ratios and then we can arrive to this particular condition. Now let us draw whatever is given in the question. What is given in the question? BD is a diagonal. So draw a diagonal BD which cuts AD. Okay. Now take any point E on the line BC and join A to E. Wherever this line segment crosses the diagonal, that point you call it as F. Now here we have two triangles. One triangle is here and the other one is here. If we can prove these two triangles are similar, then we can get the ratios for these sides, because ratios for these sides, and if we can equate the ratios, then we can arrive at the answer. Now what we will do is, to prove two triangles are similar, we can either come into a criteria where if we can prove two angles are similar, then the two triangles are similar, or three angles are similar, or three sides are proportional, then the two triangles are similar. Now let us see this particular triangle ADF. Triangle ADF. Let us take this triangle ADF. In this triangle ADF, and we compare that with triangle BEF. Compare that with triangle BEF. ADF with BEF. Okay. Now in this triangle, if you see this angle and this angle, they are vertically opposite angles. Therefore, if you take this as angle 1 and this as angle 2, angle 1 will be equal to angle 2 because they are vertically opposite angles. Now we proved one angle is similar. Now if we can prove one more angle in these two triangles are similar, then we can say that these two triangles are similar. Okay. Now what we will do is, let us see. Now you see this AD and AC, they are parallel sides and BD is the diagonal. Now if you take this forms something like Z. In these two triangles, the line AD and BC along with the diagonal, they make something similar to Z. Now what we do is, if you take this angle, angle D, and then angle B in the triangle ADF and triangle BF, these two angles, name this angle as angle 3 and angle 4, they will be equal, because angle 3 will be equal to angle 4 because they are alternate interior angles. That is it, question is done, because now we have proved two triangles are similar. When we can prove two triangles are similar, because now we have arrived at AA criteria. AA criteria means two angles are similar, means that the triangles are similar. Therefore, we can write triangle ADF is similar to triangle BEF. If the triangles are similar, then we can write down the ratios. Therefore, the ratio, suppose we take DF by FB will be equal to FA by EF. Okay. We can write one more ratio also, but we do not need the third ratio. These two ratios is more than enough. The third ratio, if you have to take the third ratio, then we can say AD by BE. Okay, but that is not required. Okay. Now what we do is, we cross multiply this. So when we cross multiply, DF into EF is equal to FA into FB. This is what is given in the question, hence proved. Okay. So, whenever you have a triangle problem where we need to prove something, first understand what is given. Okay. Given is this, it should strike to you that I can get similar triangle property satisfied, and then I can get a ratio. When you get a ratio, then you can basically arrive at the solution. Okay. This is how we solve this particular question. Thank you so much for listening. See you in the next video.